All right. Welcome everyone to the first NANOG Hackathon. I'm Sean from the NANOG Program Committee. I'm joined here by Jeff and Allison. So we're here to support you as needed with logistics of the event, make sure the programming goes well. We've worked closely with Facebook, who has graciously sponsored this event. They provided some of the infrastructure, worked with us on the programming, the repository, and they've also brought some giveaways that we're going to offer up during some of the breaks and during a small reception at the end of the day. Just some quick logistical information. So everything as far as the catering throughout the day is going to be in this room. There's catering as coffee, drinks, and other refreshments on that side. We ask that you don't gather on that side, but rather come to the high tables over here and make sure that there's space so people can go get refreshments, come back to their tables. The restrooms are out in the lobby to the left. So just go out the doors, take care of what you need to do, and come back quietly. We will have some music in the room here to keep you entertained. The lighting we think is adequate, and we tested power at all the tables. But if you have any issues with power, internet, or anything else, come to the back table and find myself, Jeff or Allison, and Dave and Brandon can also help with any logistical issues with the server infrastructure and VPSs. All right, so I'd like to hand it over to Brandon, who's going to give a quick overview of the hack and the day. And then, as I said earlier, we're going to split up into teams just on an informal basis, have you play a bit of musical chairs, pick your hack. If you want, you can work on one hack, even move to another. It's a pretty informal hackathon, so that's welcomed.
Hey, hello everybody. Good morning. There we go. All right. So first of all, my name is Brandon Bennett. I am a network production engineer at Facebook. Me and David Swafford are going to be your MCs for this hackathon. So welcome everybody. So welcome to the first NANOG Hackathon here in Chicago. We know you gave up maybe some barbecues or something else to actually come out and actually code with us and sit in a dim, dark room. So thank you very, very, very much for coming out, and thank you, NANOG, and everybody else who helped put this on. So this is awesome. I'm super pumped. I hope you are. So first of all, I'm going to do a quick poll. Who here has done a hackathon, either at work or external before? All right, excellent, excellent. How many of you have done an external hackathon outside of your work, like an IETF one or something? Okay, excellent. All right, now here's the important question. Who here, this is their first hackathon ever? Yes, that's what I want to see. Welcome, welcome, welcome everybody. So for those that are new to hackathons, let's kind of talk about a little bit about what a hackathon is. Well, first of all, we got to find what a hack is. So contrary to what you may have seen on a local news media outlet, a hacker is not somebody that wears a ski mask in a dark room in front of a computer screen. Okay, well, if you brought your ski mask, feel free to wear it. This is a judge-free zone. All right, so a hack is really, trying to get something to work. You usually have a bunch of duct tape and some baling wire, and you're just trying to get it to work, right? So that's really what hacking is, and that's kind of the idea behind it. Is we've got a limited amount of time here, and we actually need to put something together and get kind of a prototype working. So hackathon. So really the idea with the hackathon here is that, yes, you can hack in your basement, on your computer all by yourself. That's a whole lot of fun, but it's even better when we get a lot of people together. So the real idea here is working with your peers and learning and creating something cool together, right? So that is really kind of what we're going off of here. So hackathons usually have a theme. This one's no different. So the theme of this first hackathon is source of truth. And the idea here is really like take a traditional network. There's a bunch of network gear that's out there, and then network gear usually has configuration on it, and that's really the operational state and the configurational state of that device is really what defines the network. What if we instead have that as a byproduct and actually have a central database that can have all of our network, our desired network state in it, and the configuration is really just a byproduct that comes out of it. So what kind of backend systems do we need to build for that? Do we need a database? Do we need something else? And what kind of tooling can we actually build around that? So once you have a central database, what is possible at that point? What can you automate? What can you get away from manual configuration? So that's really kind of the idea, the source of truth here, and that's kind of what we're trying to do. All right, quickly agenda. So we're doing the kickoff right now. I promise I'll get done as soon as possible so that we can start hacking. There'll be lunch at 12:30, followed by some more hacking, which is awesome. 2:30, we're going to bring in some snacks, the snackathon. First snackathon. And then we're going to do something called the prototype forum. And that's really, I'll talk about that in a little bit. And then we have a table full of goodies there. So for showing up, we're going to do kind of a raffle for all those goodies. So didn't know that, but you're going to get a lot of cool stuff. So prototype form, going over that really quick. So prototype form is really just your way of showing off your hack. And that's really kind of show off the cool stuff that you've done here. So it's about 5 minutes. Do a demo of your hack. If you have a CLI or a web interface, you'll show that off. You can show off your code if it's kind of more of a library type thing. You can have slides if you want to. Do whatever you want. If we have time at the end, we'll do questions for everybody in the hack, but we'll hold those off because we want more hacking time and less talky time. So for those that don't know what to hack on, at the end of this presentation, we're going to have people that are going to lead up a hack. So people that want to have people hack with them, we'll have them kind of talk about that. So if you don't already have a hack yet, don't worry. We'll have groups that you can jump into. But here's a couple examples of what you can hack on. There was, if you're on the Hackathon mailing list, which you guys should all be, there was a huge list of great ideas that were submitted to that. So also check out that. I didn't get a chance to add those to the wiki, but there is a great list of things that you can hack on, and then we'll have groups as well. So there's refreshments in the back. Feel free to grab them at any point. Again, snacks come out at like 2:30. We've talked about most of this. There's easels at each one of the tables. They're great to collaborate on. And then Swafford's going to talk about some VPS servers. So we actually have some VPS servers brought to us by Linode that we can use to collaborate to run code on. If you're a Vim guy like me, then I'll Vim on them. And then quickly, I have just some tips for working in teams. So it is very easy for us just to find our friends. If you kind of notice, all the Facebook people kind of started or all up this table as we're chatting. So it's really easy for me to just like work with people I know, but we got a unique opportunity here to work with a bunch of people that we don't know, and that's really, I think, going to be a lot more beneficial, and you'll get a lot more out of this if you try to work outside your comfort zone and work with somebody new. Create a punch list for the things that you're going to work on, so you can split up the tasks and everybody's working. The other thing is pair programming. If you're not familiar with pair programming, it can be very, very, very helpful. So the idea with pair programming is you have one monitor, one keyboard, and two people, two or more people. When you get kind of stuck, you kind of have people jump back and forth. It's really kind of a cool thing. Give it a shot. If you've never done it before, it can be very useful, and it's great in a hackathon event. And then you need to find some way to share your code. Use GitHub, use the VPSs, use something. Other than that, this is not work, guys, right? So find something that you want to work on, and this is going to be fun. If it's not fun, we're doing it wrong. So, and with that, I will give this over to David, and he's going to go through some example hack code and a little mini tutorial for us.
Thanks, Brandon.
And while he's getting set up, I'll just mention that on Tuesday during the general session, we're going to have an overview of the hackathon, some of the results. We're also going to ask you to fill out a survey, and I'll show that at one of the breaks, but that's to sort of inform us how we could improve on this idea and continue doing it, what you liked, and get your suggestions. We potentially could turn it into a longer hack next time, so that's certainly input we're looking on, because obviously in a day you can only get so much done. But you are welcome, for everyone that's, I think most of you are staying for the full NANOG, you're welcome to get together during the breaks. We do have breakout areas where you can continue to work on your hack all week if you want to.
Cool, thank you. Just to follow up on one thing that Brandon just ended on. So we do have a whole bunch of Linodes, which are virtual private servers out already running that we're going to be providing to all the groups. These are just running a standard Ubuntu Linux server with some of the utilities that you might find helpful as a programmer, such as latest versions of Python, Golang, Perl, all those great things. And it's also got some examples pre-staged for you. So if you came here without a hack in mind or wanting to try something different, totally new, we've got the example hack that I'm going to walk through right now actually loaded on those as well, which I'm going to walk through. So following on this theme, so we've all got some different ideas going on here. So one of the ideas as we started pitching this original hackathon idea is that we were talking at Facebook one day and we're like, it would be really cool to open source this like massive system we have called FPNet. And then we're like, well, how can we do that without like making it rewritten from the ground up, because it's very integrated into Facebook. And so what we're talking about is at the core, what is it? So when we turn up network devices, what makes us kind of interesting is that we don't turn up network devices by configuring them first. We go through a bunch of tooling, we build a model of the network based on having the entire network already modeled or described in database form first. And so in this database, we have everything from simple location data to device names, all the way down to the individual BGP peer sessions and all their attributes described in a database first. And then we go build the configuration just by asking the database all of those pieces of data to build. So I'm like, okay, how would we do this if we started this from the ground up? So that's kind of what I've been working on for the last few days, is to just start building one of these systems fresh. So what I've got here is an example hack that we're calling just NetDB for lack of naming. And it's simply a MySQL database that has been pre-staged with a network topology. Actually, with a network topology like this one here, where we are following our old cluster model, where we have a bunch of rack switches connected to like aggregation layer or cluster switches. So in this example database, we have 128 rack switches per cluster and 4 cluster switches described or modeled for 2 data centers each. And so I'm going to just walk through a little bit of the code just to give you an idea of what's there. And this is actually also going to be one of the hacks that I'm going to be working with. So if you're interested in working on this, this is something I'm going to be like leading a group with. And so on the Linodes, we're going to be passing out login information for it. Your username for that will be just hack. So I'm logged into one right now. And in the directory, so when you first log in, for example, you'll see a handful of directories. There's one called build, one called hackathon, and one called tutorials. Hackathon is the content I'm showing you now. Tutorials is any past tutorials we've taught at NANOG, in case any of that data is interested in continuing hack on. But if we go into the hackathon one, there's a few files in here. One which is called topologymanager.py. This is meant to be the example API for interacting with this database. And I've got a very lightweight, minimal CLI as well. And the CLI is really what I want to show right now. So this little CLI gives us a few different options. We have modes that are, we simply have a mode called view. And so we can say view. And this database, if we look at the wiki on GitHub, which I'm not going to bounce through because that's distracting right now, but on the wiki for this hackathon, I put some documentation with this. But it follows this model where we have at the top level environments such as lab or production. And then under that, we have all the data we're going to describe, such as locations. And then under locations, we'll have devices. So if we look at this, for example, if we look at view locations, we can see, sorry. So if we give it the command view locations, it'll just do a quick database query and say what are the locations that we have already stored. So here we have ATN and FRC, just nicknames for these example data centers. And then we can also say view devices, and it's going to spit out a whole bunch of devices that we have. So this is not too interesting right now because it's just a bunch of random data, and I'm just dumping the data that MySQL is giving me. But if we take a look at one of these rack switches, this is where it gets a little bit more interesting in that I've got some example circuit data already modeled in here, which is the way we describe how two devices connect to each other. So if we look at view circuits and give it a name, it shows us now the 4 uplinks from that device connecting to another device. So that's in a nutshell, the example I wanted to show. All of this code is on the VM right now, and the MySQL database is actually running on everybody's if you want to poke at it and play with it. That now leads us into the hack pitches and all that. So with that note, I'm going to be running a small group. I'm going to be at this back table here. So if you're interested in working on this, I kind of am going to do a hack where we're going to build from this and try to go to the idea of taking this data and now generating some configuration from it. So we don't have enough data in this database to build a full config file, but we do have now circuits that could describe what our interfaces are and things like that. So if you're interested in that, hack with me. But thank you.
But Andy, what's the name of your hack?
The name of the hack is NICinfo, which is about an RDAP client, a command line RDAP client that we have. And what we're doing with it is we're just adding features.
And can you tell us a little bit about it for the group that's working on this hack?
Yeah, the group is composed of 3 of us. 2 of us work for the American Registry for Internet Numbers, myself and Eric, and Sandy is another software engineer who comes from an analytics background. He joined the group because he wanted to do some Ruby hacking.
Okay, and so you said you've encountered some challenges. What are some of those challenges?
Yeah, so we had a list of, we thought small things we wanted to add. For instance, one of them was adding, taking IP addresses and getting CIDR blocks out of a start and end range. And that seems like a straightforward problem that can be easily handled by importing a library. And we found some libraries that don't support v6 very well, which is a no-no. So we had to back up and try some other avenues. And that's basically involved doing a lot of hard math. Which they're currently working on, but they're going to get it done. And some of the other challenges, while they were working on that, we went ahead and picked some of the other low-hanging fruit, like creating more tests, and creating a build file, things like that.
Great. Is there anything else you want to tell us about the experience of the hackathon?
Yeah, I think it's been interesting. I wandered around to some of the other tables, asking them what they were doing. There were some people doing some JavaScript over there, and I was kind of interested in that. I actually went back to my laptop and they were having a problem, and I looked it up and went back over there and helped them. So it was kind of interesting seeing what they were working on. And some of the other groups seem to be doing a lot of network automation. And in the whole process, I thought of just a general tool that might help them in their tasks. And I might start working on that when I get back.
All right. Well, thank you very much. I appreciate you leading the hack for us.
Thank you.
Can you tell us a little bit about what's the name of your hack?
Yeah, so we came up, it was actually one of our challenges, was coming up with a name. So we're actually going to call it PyCon. That's P-I-Con, not PyCon, which is the Python conference. So just to be ambiguous, I guess. So that's the name of our hack. It is creating some self-registering, some call home Raspberry Pis that act as console servers. So
it's really easy for a field tech to grab just this little small $35 console server, plug in a 4G card, and it registers back home to get this information. So, or to register itself so that you know it pops online. Then you can access that, or a script to go out and access that. So that's kind of the gist of what we're trying to do.
It sounds like it'd be very useful for operators, and particularly large data centers, colo facilities.
Yeah, there's no
network
reason. So it works really good for like that initial deployment phase, but there's no reason why you can't set this up and plug in a whole bunch of USB serials into it and have it work as a full-blown console server.
Any specific challenges you've run into getting this to work? And
besides naming, not entirely too much. Everything is going pretty smooth. A lot of it is just taking different Python modules and marrying them together and putting some pretty GUI stuff around it. So.
And as far as that, the group you have Hackathon, so you all, did you know each other before? As new?
Nope. I don't think any of us knew anybody else here. So we were able to kind of jump in and start working on different parts of it. And we're now at the point where we're starting to put everything together. So it's pretty cool.
All right, one last question so we can let you get back to that. Anything you want to share, or any of the rest of you about the hackathon?
So the presenter this morning was amazing. And outside of that, no, I'm just really glad that we got this hackathon going. It's really great to see everybody here, collaborating, hacking, talking, getting excited about what they're doing. I really thought NANOG should have a hackathon, and I'm looking forward to the ones in the future.
Yeah, in the first 15 minutes this morning, it was already value talking to people, getting new ideas, and seeing. This is my first time being at an event like this, and like being around people with different backgrounds and different skill sets. Right away, there were a lot of different ideas for ways to use tools such as this, and all the ones that people are working on as well.
All right.
Yeah, it's just talking with different people. You start to get exposed to things that, like, you've got your way of working. You perhaps have done your own project. You've kind of got your own groove going. Already, I've been exposed to Python 3 and SQLite, neither of which I've ever touched before. So it's been really good.
All right.
Well, since I'm a graduate student, and it's been a completely different experience for me. So this is my first hackathon and first time. Actually, I'm programming something which I can see the results of. So huge takeaway is that I got a huge exposure on what's going on, and I'm working with guys from different parts of the who have been almost like 10 to 15 years experience in the networking field, and with 0 years of experience. I thought it would be intimidating, but nothing. It was smooth and it was like perfect. So I was able to contribute.
Cool.
Yeah, it was good.
All right. Great. Thank you very much.
Thank you.
Can you tell us what is the name of your hack?
So we're implementing black hole route monitoring on a global basis to look at where black hole routes are announced and to discover them, and we can use them for various reporting analysis.
And so that'd be a security application, but also you got some researchers, and so it might be a research application.
It'd be a service potentially for alerting for those who are interested in perhaps traffic that they have destined to those black hole routes that they wouldn't otherwise know about. It might be useful for researchers to do some measurement on. It may just simply be a curiosity for those to see sort of where the dirty hosts are that are sort of under the most duress.
And have you run into some challenges working on this project?
Well, the initial challenge we actually solved. The initial one seemed to be it would be difficult to actually go out and find and be able to parse all the route servers and looking glass servers to obtain all this data. You first have to discover how people are announcing their black hole routes, what next hop address they're using, or what community string they're using, and then see if that mechanism is available to extract that off their looking glass or the route server. Turns out you can do that to some, but it would be enumerating over all these systems and having to code up things individually. But one of our teammates has actually a project previously worked on that actually presents or eliminates a lot of that problem because they have a stream of BGP data. In fact, it's a project called BGP Stream at CADA. and all the routes that they see are populated in one consistent format that we can extract all that information out of one place. So all we really have to do is discover what community strings people are using and what next hop addresses they're using. We don't have to go parse a bunch of different systems independently. So that was a challenge. So now our challenge is now just figuring out how to put all this data together and what we can use it for and come up with cool applications once we've stuck it all into a database.
Okay, and all of you are from different organizations, different backgrounds. This is the first time you've worked together?
I've known one person here prior, but we've never really worked together before. So I think that's true of most of us. We're a brand new team.
Good. Is there anything else about the hackathon you want to share with us?
Yeah, I would say maybe everyone seems to have their own unique role that they're playing. Some people are really good at some database things, some people are good at programming. We even have some graphic arts talent in the group, which all of these things combine and put together, fill holes that some of us have in certain areas. As a team, we have a holistic solution.
All right, well, thanks for coming, thanks for leading the group, and thanks for sharing your experiences with us.
Thank you.
Can you tell us what is the name of your hack?
Sure. We're working on a hack. We're calling it Takeoff. The problem case is that pre-flight testing is generally very standardized, but it's almost always done manually. People have checklists they go through. They look at the output. They run command A, check. Okay, the device is good. Let's bring it to production.
I don't know if that's good.
Why are humans doing that? So we're working on a fairly generic framework that anybody can write to an API to create a device unit test. And this, you can check whatever you want in this test. The API returns true, false, pass, fail, and then once all the tests passed, you can build in a step at the end to say, all right, all the tests are good. Bring this device into production and push whatever config changes are necessary to have that device, put it on the network, and have it handling production traffic.
And in working on that hack, what are some of the challenges you faced?
Okay. The biggest one, I think the two biggest challenges, the first off was just coming up with a framework. Okay, what is this going to look like? What is the same framework that I can give people to write to that aren't, that's simple enough that anybody can write a Python module, and as long as they adhere to that format. So coming up with something that's plug and play enough that a large number of people can jump in and start making tests. The biggest problem we had in the context of this particular environment is actual testing. People are creating VMs in their laptops. Peter was running Arista and running into some issues. Just getting a good test environment where we can actually run this thing and watch it go, so we can have something to demonstrate at the end.
And have any of you worked together, or just organically came together?
This is all organic. I'm meeting most of these people for the first time.
So you have a device,
so
you could then have
And how is that? Is there anything else about the hackathon, or just the group you like to?
This is. I mean, I've done. This is the first third party. I mean, we've done things at Twitter but it's when I've done with those, it's always been my own coworkers, people I know. This is my first experience coming in with an idea and just saying, hey, let's all work on this. So it's interesting learning because you don't want to come in and just be prescriptive. This is my idea. Here's how we're going to do it. Okay, you do this. I mean, you got to be collaborative. So you have to do it you have to make decisions in a very short period of time, as opposed to something where you might have a meeting over the format. It's hey, let's make a decision. Okay, done, go.
And so this was our mega group, I think, with 9+ participants.
I think so.
And it all came from a 6 o'clock idea in the shower.
Yeah. I literally thought of this not much. I had been coming here planning on finding an event to join. what projects are out there, whatever was interesting, I'll join it. This morning, literally right out of getting out of bed, I just thought of this and said, hey, I'll send an email out and see if anyone's interested. And well, people are. It's kind of cool.
All right. Well, thank you. I apologize for taking away from the coding, but
Oh, no problem.
appreciate you telling us about the experience.
Okay, great. Thank you.
Can you tell us what's the name of your hack and the challenge that you're trying to address for operators?
Sure. The name of our hack is, it's all really about automating maintenance notifications. And the problem we're trying to solve is that maintenance notifications today, they're really hard to build automation around. And that has to do with the fact that they show up in varying formats. Every provider has different ways of formatting the messages, and even within a provider, they're not consistent about their formatting. So the way that we're trying to address this problem is by creating a standard format we can use, and then providing some example code, as well as some hacks that we're developing here today that make use of that example code to do interesting things. So for example, we're working on one where a properly formatted maintenance will result in the generation of a ticket within a ticketing system.
Great. And what are some of the coding challenges or structure, other things that became hurdles as you started working on this problem?
Yeah, I think some of the challenges that we've encountered today have been trying to work through all the different possible use cases for this, and different ways in which it might be consumed, interpreting standards that exist that we're looking to extend, trying to understand what was meant there and how to make use of it.
And as a group, have any of you worked together before, or is this something that organically came together here to tackle this problem?
This is a problem that I've been working on with a large group of people for about 1.5 years now, but everyone here today, we're all new. We haven't known each other before. And we came together because I put out the appeal, and these folks kindly volunteered to help.
Great. And anything else about the hackathon, the experience that you didn't anticipate or like to share with us?
This has been a lot of fun. I've done these sorts of events before within my own company. I've yet to do one with people from different organizations. It's been great to see a lot of enthusiasm and interest in this area from different people. Acknowledgement that this is a common problem that other people have and are interested in solving.
All right, great. Thank you for taking the time. We'll let you get back to your coding.
Great,
and
thank you
we'll
much.
look forward to a report at the end of the day.
All right.
All right, thank you.
Thanks.
Can you tell us a little bit about your hack? What's the name of it? What problems are you trying to solve?
Yeah, so the basic problem that we're trying to solve is that TACX servers haven't evolved since the late 90s, and that kind of sucks. It makes running them in production kind of terrible. So both to alleviate this problem and to learn a new language, in this case Erlang, we are writing a new TACX server, just wholesale from scratch, from the protocol spec. It is appropriately named TACX because we don't like fancy names here.
And what challenges have you faced? Obviously, learning a new language.
Yeah.
You're dealing with a protocol that's been around for a while.
Yeah, a lot of it has been learning Erlang. A lot of it is also that the protocol spec for TACX kind of sucks, and I want to strangle whoever wrote it at Cisco. Not to make fun of anyone who works at Cisco here.
And as far as your group, how did it come together? Have you worked with any of you worked together before?
Yeah, so Anshul here works with me at Facebook. He's also on the network engineering team. The other folks who were sitting here and the people who are, I've literally never met them before in my life.
And they were all enticed by the idea of new language?
Yeah, literally every single... Yeah, everybody came to me and was like, hey, this Erlang thing sounds pretty cool. We'd like to learn how to do it.
All right, and overall, what have you felt about the hackathon? Is it?
I love it. I mean, I come from Facebook, so this is a big part of our culture internally. And I'm actually kind of heartened to see how many people showed up for this. And I really hope we get to do this more in the future. This is a lot of fun.
All right, anything else you'd like to tell us about? Or?
Not that I can think of. No, just keep on keeping on.
All right. Well, good luck finishing up the coding. We look forward to seeing the report at the end.
Thanks.
All right. Can you tell us the name of your hack and what problem you're trying to solve?
So we haven't really come up with a name. We're just calling it Messenger Improved. So what we're trying to solve is Facebook a couple years ago had a desktop app for Messenger. For programmers like myself, it was great because I was able to like message people from my desktop. And I was able to just send off right from a toast notification and send off a message. Well, when they removed that application from the market, they removed that feature. So every time, like I have a lot of chat groups online with a lot of my coding buddies like Ethan and myself, we chat all the time between Messenger. So for us, a push notification would be great. We'll type in a field, we'll enter, we don't even have to leave where we're coding. So a lot of people right now, if they're talking on Facebook, they have to go to Chrome, open up a tab, stop what they're doing, and then send a message and go back to what they're doing. So what we're going to do is completely eliminate that process and allow people to just send messages within seconds rather than flicking back and forward. And
just basically have like a pop-up bar. It's like it overlay over the desktop. You click on it, reply, you hit enter, it disappears. You can just reply simply over the desktop instead of having to go all the way into a program or open up a tab. It's basically overlay over the information, just like a text message.
And earlier you told us you're integrating a number of different things. You got to scrape some JavaScript, and you've run into some challenges with that.
Yeah, we're having fun with Java right now.
What's that?
we're having fun with JavaScript right now.
Is that your major hurdle that you've encountered?
Well, our biggest hurdle is Facebook doesn't allow iframes for, like if you load in a website like Facebook will not load in an iframe. So we were able to get it to load in an iframe using Node WebKit and Angular, which is powered by Google. Google had Angular, which is a Node WebKit or a Node.js derivative. So we were able to get it to work in an iframe. So now that we got past that layer, we got the notifications working. We're trying to push it all together now and create the platform. So hopefully it'll be all wrapped up in the next couple of hours and we'll have something to demo.
All right, and you said obviously the two of you have worked together before, so it was pretty easy to sit down and just...
Yeah, we're just hashing out problems and throwing ideas off the wall, and it's been fun. So it's a great opportunity for all of us.
And have you interacted with any other groups?
We have. Morgan over there has helped us tremendously with some JavaScript. He's coming in and showing us how to do a couple of things, so it's great to have his help. And we're going to go back and ask him for a little bit more help, too, because we got a couple other questions for him. But it's coming along. It's coming along nicely.
So it's been a good overall experience?
Yeah, it's been a great
experience. It's been awesome.
It's been a great time.
All right. Let you get back to coding. And,
all right, thank you.
Can you tell us a little bit about what's the name of your hack and what are the challenges for operators and networking community that you're trying to solve?
Yeah, so our hack has been around building a source of truth, kind of focused on this hackathon's theme of trying to figure out a way to have a system that describes what your network looks like without having to ask the network devices themselves, because that gives you a lot of flexibility in terms of not having to trust what's on the device to go build it. So what we started out with was like an example network topology that you can actually kind of see in this picture. I don't know if you can actually get this or not. But what we've got here is actually a small graphic showing a whole bunch of racks and their upstream aggregation layer devices visualized right now. Where in this database we describe the devices and their names and actually describe how they connect to each other. We started out the hack today with going into configuration generation. So looking at the database and trying to render a very simple template of what is this host name and what interfaces are on the device. Because we wanted to be able to generate at least some config based on that. And we finished that actually pretty early. So these guys over here found this awesome visualization tool. And so we've been working now on just trying to make this UI actually representation or UI work for it. It's coming along pretty neatly.
So you started out with an idea and it's actually grown.
Yeah, well, the first idea was actually easier than I thought for these guys. So I think that we were done by the morning, and then we're like, what's next? And then we're like, well, we've got all this data, let's visualize it. And then we got the visualization working. So now they're trying to actually work on per device visualization. So we have in this example topology 128 racks. We're trying to make it so that when you zoom in on this, you could actually click on one in specific. Sorry. You could actually click on something in specific and actually go to a more specific page about that rack and what it connects to.
And a little bit about the team. Have you guys worked together? Did it organically come together?
It just organically came together. The only person I met ahead of time was Andrew with Linode, just because he helped us a little bit with the Linode setup. But everybody here we met pretty much on the spot. I think these two guys work together because they're with the same company, OpenDNS, but it's been kind of cool just having random sources.
Great, and I know you said you've done a lot of internal hackathons at your company, which is Facebook.
Yeah.
What's it how's it different coming to this external third-party hackathon?
One big change that I've never done before that was really cool that I think worked well at this one is in our internal Facebook hackathons, it's generally very silo and isolated. Like you'll have a few people that are super focused on their hack and they'll work really tightly. But if you're in like a new group or you're new to the hackathons, it's sometimes hard to get started or hard to hack as a group. And so what we did this morning is we were doing this idea of pair programming, where we all logged into a remote server and shared one terminal session. And so one person at a time had the keyboard, but we all watched. And then they set a timer for 15 minutes. So one person would have 15 minutes to go work, and then when it went off, we'd change. And we've been rotating throughout the day, which is really, really cool.
And have you done any exchange with some of the other groups in the hackathon?
I've talked to a few of them earlier just to see what they're up to and what they're working on. And there's a few really interesting projects going on too. But mostly I've been trying to like stay around here a little bit.
All right. Well, thank you. Thank you for taking the time. We'll let you get back to coding and look forward to the wrap up at the end.
Yeah, thank you.
All right, the hackathon is officially up, so now it's time for the prototype forum. We did our best take on the names of the groups. If you want to update that as you go up to your presentation, we can take care of that. I gave it a basically random order, so you can see where you're likely to come in here and start getting ready to come up and give your 5-minute or less presentation. So I'm going to invite the group Source of Truth up first. David, come and give us your demo. The more the merrier. And just so you know it, Brandon's working on getting the hacks into a survey site so that you can vote on them after all the presentations. So he's going to, after we get the presentation, he's going to add hacks in there. We'll get a vote in, and by the time we close, we'll figure out who stands where.
Thank you. And if anybody from my group wants to join me, you're more than welcome to come up here. They have most of the credit for this. I just kind of organized a table of people. So what we did is we were working on the hack for having the source of truth, which is our place to describe the desired state of the network in database form before building our network or data center. And so the first part of our hack actually started with diving into that database and trying to generate a bare bones configuration of our aggregation layer devices, the top that we see here. And just build a bare bone config for each of those, generating an interface name and description for every interface that we have in the database for those devices, along with the host name. So we actually did that at the early part of this morning, and we got down to the point where we generated, and I'll show you in a minute what this visualization thing is, where we generated the config for all of our what we call cluster switches, which were our top level aggregation layer. And when it loads up in just a moment, what I'm going to show you is the config that we generated. I'm not touching it. Or I might go to Vim. Let me just go to Vim for a second. And so, oh, I dropped my network. Well, anyways, if it does come back, what we generated was the configuration for our devices. And the second part that we went into was building this visualization tool. And if it comes back, I'll show you in a minute. If not, we'll continue. But the second part of it was, let's say now that we've got all this interface data and this interface data and circuit data describing how these devices connect, one of the guys at our table said, hey, let's start building some visualization of this. So we started looking at some projects, and one of the ones we found on the web is this viz.js, which was a really easy project where we combined the Jinja templating knowledge that we learned at the beginning to do our template filling in and editing. And we converted a very basic template for an index.html file using Jinja to compile basically what all of these edges and nodes are that we're drawing on this page here. And so when I zoom out, what we can see here is that everything in our example database is actually drawn on screen. Though we did have to cut down our example database from a lot of devices to a handful to make it actually presentable. We have basically 2 data centers. The top level is our aggregation layer, and the bottom level is our rack switches. And all of these nodes are actually clickable. And when we click on them, what we get is actually the generated configuration. So if you're interested in checking this out, it's hack001.netedgecode.com. But I don't want to take up too much time since we're just kind of watching it load. So with that, I'll give the mic to the next group, which is Takeoff.
All right. I'll just check. Actually, hang on for a second. I know the clock's running. All right, so we came up with an idea, and this is like a really crazy idea that I came up with this morning is, would it be great if you could have a framework by which people could contribute their own unit tests to hardware? So the original idea was a script that would we were too busy building
our time writing efficient, powerful backend code.
Okay.
With a very clean, simple.
He's better at this than I am. Yes. So
it will transform the way you manage networks.
yes.
I don't need a microphone. I'm loud enough without it. Prepare to be amazed. Hold on, I gotta fill in the time.
All right. So, whoa, that's not what we want to see on the screen. That is something. No, I just showed. Okay, how do?
Please ignore that last slide.
It could have been worse. It could have been worse. I need to figure out how to. Okay, forgive me here.
So what you're about to see, what we decided to make was a system to be able to verify that a device is healthy either before bringing it into service or bringing it back into service when it's been taken off for maintenance. So many of you have in the past, I'm sure, bought a router online, brought it up, turned it up, went home for the night and went to sleep only to get paged when all the things are blowing up because you didn't install the proper routing cable, because you didn't install the proper prefix limits, because you didn't install all the line cards or the power supplies or so on and so forth. So what we wanted to do is build a system that works kind of like unit tests for routers and then results in a full integration test and test all the things you would want to check to make sure the router is healthy before bringing it back into service.
Yeah, so we came up with an API, a base library framework, a standardized set of arguments that you write a class with a method with a specific name that takes arguments X, Y, Z, including a SSH connection object, and returns a standard format. We documented that, wrote a wrapper that looks for tests that match the signature. So someone who wants to write a test, they write a module that conforms to the API, drop it in a directory, open up a file, add a line with the path to that test. And the wrapper runs, it reads the file, it loads all the modules it finds that match that signature. So the file format lets you have a test that run on any device or platform-specific devices. You know, this is a Juniper test, this is an Arista test, yada yada. And when you run the wrapper against a device, it's going to run these tests and then report the results.
The original idea was that you would have a undrained script. So when you're ready to bring a device into production, you would call these methods, run all these pre-flight tests, and only on success do you then log into the router and make the config change that results in live traffic going through the device. We mocked up a couple tests, and the output gives you a success. So it tells you what success test succeeded.
And what tests failed?
Yes.
Okay. So here you go. We'll run it. And there you go. That easily, now you will no longer bring a router into service with it misconfigured or missing components or broken and screwing up your network.
And that's it. You can see they're proper Python modules, so I've got some flexibility to read the list and load modules dynamically. So anyone wants to write a new test, just write one, and it'll run next time someone runs it.
All right, and the next group is the mini console group.
Gets the Hello, everybody. So I'll talk really quickly about kind of what we were doing. You've already heard about it, but we got a Raspberry Pi set up. These Raspberry Pis have serial USB adapters in them, and the really idea here is that these Raspberry Pis can have 4G cards in them, or Wi-Fi, or connect directly wired in, and they should register back home, and we should know about them. So that we shouldn't have to know what the IP address on there. You give this to a field tech. That field tech doesn't have to know anything besides plug blue cable in the blue hole. So what you see here is our web interface. And every single one of these Raspberry Pis is actually sending REST information back. Right now it's at a very fast level so that we get information about them. But you can see the IP addresses that it reports back, as well as the ports that are there. The ports are actually the serial USB ports that are there. And we also get a status there. So this is updated. Like I said, these update over and over again. So let's go ahead and moving. Okay, so we just unplugged one of them. There's a little bit of a hold down. It's kind of like CDP or LLDP in the way that we just wait until we haven't heard anything for a while. And you can actually see where that Raspberry Pi went offline. So we know it's offline. When we plug it back in or modify one of the USB ports up there, it'll automatically update. Go ahead and click on one of the post names. In addition, we kind of have like just a more detailed information about it. What you don't see here is something that I was working on, which was a WebSockets interface to this, where the WebSockets, you would actually get the serial console. WebSockets and Python 3 don't work together, and I decided out of the two that should go, WebSockets were the one to go. So long live Python 3. Anything else?
That the ultimate goal here is to have the single-click console access, so that you can have this dynamic discovered list of console servers that may be deployed in remote offices, data centers, new sites being turned up, and then your admin team that's building this up, or whoever's trying to work on a particular issue, can take one of these dynamically, or these little buckets of hardware, plug it in, and get console access to anything, anywhere, whether it's over a LTE or 4G card in the middle of some new hardware being built out, or an office that otherwise has a network they can plug a network card into.
The other cool thing about this, because it's based off of USB and Raspberry Pis, that you can easily scale this up. Just plug in more serial USBs into it. Get a hub, plug 20 in them. You now have a console server that costs you less than $100.
And it just the same could be an old PC with 10 PCI cards that each have octal breakouts and some overly expensive serial cards as well. So anything that can dynamically talk to this can register all its serial ports, and you single click to access them once the WebSocket supports Python 3.
Cool. Thank you.
All right, thank you. And the next group will be automating maintenance notifications.
All right. Since the network doesn't always work for me today, this is PowerPoint. So most of you, I believe, have worked with maintenance notifications at some point in your careers. Raise your hand if you haven't. All right, so for maybe about the 10 or 5% of you who haven't, here's some brief background. So maintenance notifications are messages that are often exchanged via email. They are about services that you either provide or consume, and they're notifications that that service is about to undergo maintenance. You want to know about this so you can take that service out of your production requirements so that whatever you're doing isn't impacted by it. These messages are often manually processed. There's something that some human sits and looks at and then decides what to do with. And that's often a laborious task. It can mean things like adding entries to calendars or opening up tickets, generally doing a lot of stuff that computers are better doing than humans are. That's what we want to do. But we have trouble with that because it's hard to build automation around these things. The information in these notifications is often different on a per vendor basis. Everybody does this a little differently. They're designed for humans, and it's hard to automate. So we've been working on this effort for a while now, and today at the hackathon, we did a bunch of work related to it. We improved our draft standard for the formatting of these messages. We've expanded it and improved it. It's a lot more consistent. It covers several additional use cases we hadn't thought of before. We also worked on our Python library to expand it and improve it. The generation and parsing tools do more than they did before, and they're better aligned to the standard. We also added support for generating tickets automatically, and you can go to GitHub or the other link there to look at our work. Quick screenshot here of what this looks like. Here's an example of creating a ticket. Their initial comments describe what the properly formatted information is according to the standard. A couple function calls later, and you get this, which is pretty exciting if you've spent a lot of time and effort doing this kind of work manually, as I have in the past, often doing things like converting timestamps incorrectly and causing outages. All right, any questions or feedback? We'd love to have it. Join our Facebook group to track our progress. Thanks. Next, we have Black Hole Route Monitor. There we go. Awesome.
So one of our challenges was to go out and see if we could gather black hole routes that are sent into IXs and ISPs. And one of the challenges that some part of the team was really interested in was being able to do something with that data in form of a troubleshooting process, making it very user-friendly. So the initial plan was to go find all these places where we could find the signals for trigger black hole routes that are all over the place. If we can catalog them, store them into a database, write code to literally have to potentially parse telnet output or web output to gather all that, stick it into a database, and then see what we could do with it, building tools and so forth. Some of the challenges for doing this clearly was the parsing part. This is something I brought this initial idea to the team, and this is the thing I thought I would need the most help with, is doing that parsing. As you'll see in a second, we reduced that effort significantly thanks to a contribution of one of our team members. Someone else had raised the issue of, well, when you start doing this, those who are making their route servers publicly available and the consequently, the black holes, maybe they might stop actually doing that and sort of eliminating this useful insight for us. So I hope we don't encourage people from hiding that, but that's a potential challenge that we may face. Here's the project that we had sort of a ringer at our table from Kata, who's been involved in developing this very elaborate but very cool tool called BGP Stream. I challenge you to go, or encourage you to go check it out. This was something that really helped us eliminate a lot of that custom parsing and polling of different looking glasses and route servers. A lot of that route data goes through here, and we could just use the source of this data in an aggregate format to get a lot of what we were after. So here's a little bit of what all, it's not actually very difficult. The minimal amount of code is what you see here. You just set up some Python objects, you set up some filters, you say what you're interested in, you get essentially a dump of the data from various routing databases which you can parse and then work with. So you can parse based on community tags, or you can parse based on next hop, and so in one of those two cases, that was ideal for us to create this data. So we put together a database schema, and we started populating database with data. We started writing tools to do stuff with the data in the database. And some of the most basic forms, which is where I came in, because my coding skills was probably at the mediocre level for our table. So I wrote some text-based reports to create like a data feed, and some other people wrote some web interfaces to this, nice query interface, and we even had a cool logo. Some of you have heard of this command, who am I, on Linux, so we have this am I dead logo, so you can check to see if you're a black hole or not. And I think the logo is actually apropos, because it's like this spinning wheel of death thing that you'll see, right? Here's what the database might look like. I don't know if you can perfectly see that in the back, but basically you have rows for where the data come from. And in the screen here, you'll see DKICs. There's a lot of data that came from where's the route. Some of these routes are just /32s, others were larger. What AS was originating it, and when did we actually see it? We did some aggregating of data, so we could do like top 10 lists and that sort of stuff. So that was kind of fun and interesting and useful. If you want to look at a little web interface, if you want to see if you're dead or not, you can use this interface to query it. That was almost about 5 minutes.
Folks can see my console okay? Cool. So I really love how you can tell the presentations here that were made by people from Facebook because they don't have crazy slides. So congratulations all you people who did that. You're more polished than the rest of us are. So my group's goal was to take a sort of shell of a TACAC server that I've been working on for the last week, sort of help carry it over the finish line. I could show you a retro terminal, or I could show you a bunch of Erlang code, but I'm pretty sure that none of you really want to see that. You want to see what it does. So with the help of Anshul, we've developed a totally real shell, you guys. Switch that actually emulates a production switch, right? So this was sort of a test. It actually uses a Ruby TACAC client to contact my server. So if I log in as myself, welcome, I can show commands on the switch. If I run it as someone else and I try and log in as test, the server will deny me access. Although apparently it actually just did, it gave me access to the CLI anyway. But you can see that it said access denied, so the best security, right? It also implements the authorization protocol. So if I log in as myself again, and I do show run, it succeeds. But if I try and say hello to the switch, it tells me to go fuck myself. So the biggest challenges of doing this were obviously the weird language that I decided to use because I'm a hipster, I guess. But that being said, it was a really great experience learning Erlang for this. It sort of required me to map a lot of my brain to be able to do this, and I think I managed to teach some of the members of my group a little bit of how to do it too. Hopefully, I'm sort of hoping to carry this a little bit more over the finish line in the coming weeks, and maybe get this deployed into production at Facebook. That would be awesome. So cool. Thanks, guys.
All right, and next up is our Noah's Ark group, the 2x2 team that had 2 hacks, and so I think we're going to find out the second hack, right?
Cool. Yep, you will. All this and more. Let's see what we got here. Hopefully this works. Oh, this mic will be fine. Our handheld will actually be fine. I'll take the handheld. Figure out how to mini display port correctly. Will it work? Will it blend? There we go. Okay, well, hopefully this doesn't mess me up with the resolution change, but I know you guys are eager to see our messenger kind of a hack. Well, shame on us, Facebook really doesn't allow us to use iframes, but I do take it as a little bit of a reward because we got it to work with Node WebKit, scrape a couple bits of data off of it, and we were able to get that guy working in an iframe. So I'll reopen it again since it had it opened already, but there we go, hit run, and we got our nice fancy animation, and we have our messenger. So yes, it wasn't completely built. We didn't get the ground notifications like we would like to. It was a little bit of a challenge. I couldn't JavaScript fast enough. I wish I had 10 fingers and 2 more people, but 2x2. Okay.
Thank you, and now our Nick Info project.
All right. So we basically added a couple of features to Nick Info and had a couple of challenges, but we got over them. The first one we mentioned was trying to integrate traceroute with the RDAP protocol using Nick Info, and so we did get that done. Not the cleanest way, but it works. And so I can't turn off mirroring here. I can't see a thing. So here we go. This is going to show that we integrated it in. Of course, one of the problems with traceroute is you have to enter a command. You have to enter because the ICMP, the Ruby ICMP socket layer requires permissions. You have to be root to do it. But so yeah, so what we did is we just found someone's code that did basically did traceroute directly in Ruby, and I just kind of modified it a little bit. And what's going on here is it's I also changed it so it would only go for so long, and so it did the traceroute, and then went and did all of the RDAP queries in the background. So you can see here that the first network it found was the NANOG network, and here's all the information about it, and so forth. It keeps going through there. Then we go to an RCN network, another RCN network that we're running through, Equinix. And one of these things I did, this is a network out of 89/8, so which is I believe APNEC space. Yes. I don't know why we're routing through there to get to here, but whatever. And then here's the end layer network and so forth. So it keeps going on. You can get all the information about those networks. So that was the integration with traceroute. The other thing is, if you'll see it there at the very top there with the start and end IP address. Now this is the hack that took us for a couple of loops. We went down a couple of paths. So someone had mentioned that it would be interesting. The RDAP protocol only provides a start and end IP address, and so it would be interesting to give those things insider blocks, right? The problem here is there are some libraries that do that, but they kind of spin their wheels when you put v6 addresses in there. So we started doing trying to port some other libraries into Ruby. That was going to take forever. And finally, Sandy over there figured it out. And so now we have this thing in here. We couldn't find an example of a network that actually breaks down to multiple cider blocks, but he says it does work. So, and the other thing is we also integrated it with a RIPE command to actually give your own IP address. So see if this works. And boom. Yeah. So here it's doing it for, oh, look. And see it does the slider things for V6 as well. So that works too. So there, that worked. And I believe we also had one other feature where we created a rake file because one did not exist. And all it was doing was running our unit tests. So that's what we did. It's all on GitHub now, so you can download it if you want.
All right, thank you everybody. Those hacks were freaking amazing. And I hope I'm not the only one that feels that way. It was really great working with everybody here. It was really cool seeing what we came up with in less than 7 hours. So thanks again, and a round of applause again for all the hacks.